Today we'll cover the important topic of prototyping. The idea of prototyping is to create a prototype, and a prototype is a working demonstration of the system. It's not the real thing for sure, it's just a demo. But it turns out to be extremely important in the field of HCI because we are going to build many prototypes until we are satisfied with the interaction and the user is satisfied as well. And developing prototypes, or generally developing systems, is expensive. So instead of the actual system, we will see what we can do to actually fake out the interaction so that as if we have the real system that we intend to later on build is in front of us, and then we can test with that. So again, why do we build prototypes? Why do I have to show it to the user as early as possible? Okay, the reason why is that when you show a prototype to the user will give you a better feedback than you describing it to him or showing him just design illustrations. Okay, remember, a big part of HCI is about the interaction. It's not really an issue of whether the interface is aesthetically pleasing to the user or not. The question is the interface usable to the user or not? To achieve this level of acceptable interaction, you need to show to the user something that looks like the real thing. And this is what prototyping is all for. It looks like the real thing. So we prototype to materialize concepts that we are experimenting with, that we are thinking of, and we believe they are a better design. To structure our thinking of the interface itself, which functionality should go in where. And to manifest design ideas. You having an idea does not necessarily mean it's a good idea. When you manifest it on a paper or through a software screen or through an LCD, you can better judge your design idea. Okay, and last but not least, it's the collaboration and participation from the user side. That when you show him something, he actually can comment and discuss with you the details in a deeper level than you mentioning it or writing to him on a piece of paper. So we prototype to materialize concepts that we are experimenting with, that we are thinking of, and we believe they are a better design. To structure our thinking of the interface itself, which functionality should go in where. And to manifest design ideas. You having an idea does not necessarily mean it's a good idea. When you manifest it on a paper or through a software screen or through an LCD, you can better judge your design idea. Okay, and last but not least, it's the collaboration and participation from the user side. That when you show him something, he actually can comment and discuss with you the details in a deeper level than you mentioning it or writing to him on a piece of paper. So what are the goals of the prototype? The most important one is to solicit feedback from the user. You want the user to tell you what he believes of the system. And also to save you financial resources from developing the system, then scratching it and throwing it away, and developing another version of the system, and throwing it away, and developing a third version of the system, and throwing it away, and so on. Each one of those versions will be expensive to develop. So instead of that, if there is a fast way we can manifest our ideas or put down our design that is beyond a piece of paper, that is more like a real thing, that's actually much better than nothing. Okay, and what we really are after here is to do many design iterations. With every design iteration, the output is a new interface or a new set of interaction techniques. And prototyping will give us that, will give us the ability to create many designs very quickly, as you will see. What types of prototypes do we have? There are paper prototypes, which is the one you're going to build for your project. There are computer sketches, and there are software programs that you could use to create prototypes. Now, for the paper prototypes, this is really, it looks naive, I know. When you learn about this, you would think even it's a bit childish, but the reality is, this is what most companies do. This is what Google does, this is what Microsoft does, this is what many companies do, this is what Facebook does, this is what Twitter does, this is what LinkedIn does. Everyone is doing paper prototype. Why? Super fast. This is super fast, super easy, okay? Now, what do you do with paper prototype? You use a pen or a pencil and a paper. What do you do actually with a pen and a paper? You draw the interface. But here is the catch. You are going to draw everything, okay? You're not going to draw one illustration and tell me, oh, here's the menu, here's the buttons, here's the dialogue, and the user is going to interact with that. No, you are going to draw every single screen the user is going to see. Every single change on a screen the user is going to see, okay? The nice thing is, even if you're not good in drawing, you will get really fast. And the nice thing is as well is that you can automate a lot of the drawing process, as we will see. Where is this coming from? It's actually coming from architecture. That's what architects do all the time. Architects don't go and draw buildings, or construct buildings from drawings. They build a mock-up, a sketch, okay? You must have seen it in the university from the architecture department. They have these mock-ups of buildings that are made of cardboard. Very important in their very important step in their design life cycle. Okay, that it's not enough to put it on drawing, which is what you see on the left. The technical details are important, yeah, and everything, but you need to look at the whole thing physically. You need to have an appreciation of the architecture, and you do that by building this model. And usually they would get cardboard and cut through it to make the windows, and then color it and connect it together. And here you go. Here is a small replica of the building. So this is where this is coming from. And this is our, fantastic paper prototype. This is how it will look. It will consist of user interface controls that the user is going to be exposed on. Obviously here, these are user interface controls for a desktop system or a web browser, if you'd like, or a web page. If you're building it for Android or iPhone, it has to look and feel the same as an Android or an iPhone, okay? Once you start, you start by getting this a sheet that looks like this, and then you print it into as many copies as you like. You can print many of them actually. Probably you will need 10 or 20 of these guys, and then you will use tweezers to cut them into pieces, and then you will overlay them on the top of a piece of paper by gluing them to design every single screen the user will actually see. Okay? So this is actually how we're going to construct the user interface for your project. Now, when it comes to cell phones, for example, if you're developing a cell phone tool, there are actually utensils you can buy from Amazon or eBay, like the one at the top left, that enable you to draw on a piece of paper the different user interface controls for this specific platform. This is the one, for example, for iPhone, and you will find other ones for Android. Okay? Now, and you will even find these plastic things that appears on the right-hand side, top right-hand side image, where you can actually get a piece of plastic that looks like the iPhone itself. Okay, and then the thing is, you're not going to draw one interface. You're going to draw every single screen. So imagine if you have in your interface, the user is going to go through interactions that requires displaying 50 different interfaces. You're going to draw the 50 interfaces. Okay, you're going to draw all of it. Okay. But it doesn't stop here, as we will see. Now, and this is just again to highlight the idea, I'm going to fake the whole thing using user interface controls drawn on paper. They could be made up out of cut pieces that you got them from a template, where, like, for example, here in the image at the top, in the center, top center, you see the scroll bar is being cut from somewhere else and glued to this piece of paper, where this is actually the user interface. Okay, now, and you see in the top right image, the user is holding a piece of paper that simulates the interface of a tablet. So he's holding it the same way you would hold a tablet, and he's pointing in the same way you would point to a tablet. So you have to use the same user interface controls for the platform you're designing for, and the interface has to be complete. Okay, and using a bunch of scissors and downloading one of these templates online, or you making up the template and printing it many times and then cutting it into pieces and gluing it around is the fastest way to go. Okay, and this is what's beautiful about paper prototypes. You can build a whole prototype that contains dozens and dozens of screens in a single day. Okay, if you know what you're building, or you're experimenting even, you can do it in a day or two. Okay, so it's really fast, and that's why all companies are doing it, because they won't just design one interface for an application they are creating. They would design perhaps 4 or 5, and each one of them is a complete interface from A to Z, and all of it on paper. And that enables them to actually inspect the interface more in a more direct way than just to, think about it or describe it, or just use a program like Adobe Illustrator or Adobe Photoshop and just scan it, or sketch it, or just connect it together using some drawings. Okay, this is now, it looks like almost it's the real thing. How do you go about using this so it gets as real as we can ever get it to be? This is what we do with Paper Prototype, and again, this is what you're going to do with your system, and this is what you're going to show me in the video that you're going to make for your system. You actually are going to need 4 people here to get this done correctly. Okay, one will be the actual user, and in your case, because of the COVID-19 situation, you will be the user. Okay, you will substitute a real user, because I don't want you to go out and meet people. Okay, now who are the other 3? One of them will act as the computer, which means he will have all the interface drawings, and he knows exactly what are these drawings and how they are interconnected. And when the user touches, say, a button, he will take away the paper in front of him, and he will put another paper that has the interface the user would have seen in real life, if this interface was actually built in software, I mean, and in hardware. So the computer acts like a real computer, changing the screen in front of the user. In this case, the screen is the paper prototype. Another individual will act as what we call the facilitator, and in this case, he will be explaining, and this person will be explaining to the user what is he looking at, and he will tell him what to do next. Like, for example, he would put the home page in front of the user, or the computer will put the home page in front of the user to be accurate, and the facilitator will tell him, please log in. So the user goes and looks at the paper in front of him and trying to find the login button. And if he finds it, he clicks on it by just tapping on that area in the paper. Once he taps on it, the computer will interfere and will take the paper in front of the user and put the other paper in its place, which will have the username and password dialog. Okay, the user simulates typing the username and password and presses login. The computer again takes the paper in front of the user and puts another interface on another paper, which has another interface, which is what the user is going to see after he logs in successfully. Okay, someone else is going to be taking notes. What's happening when the user, for example, is told login? How fast did he identify the location of the link or the button that he's supposed to click on to log in? Did it take him like 2 minutes? Did he go and ask the facilitator, like, where is the button? And the facilitator told him, oh, it's over there, can't you see it? So this kind of interaction that will happen between the user and the facilitator will be monitored by the observer. Okay, and he will write notes. Oh, this is easy to do. This was hard. He made a mistake here. Okay, the screen size is a problem, and so on. Okay, and someone will be recording all of that. The idea of the recording is later on you can sit and watch the video and reflect on how the interaction went. Okay, so this is how you simulate with Paper Prototype a real interaction. If we were not facing the COVID-19 situation, you would have going back to the example of the dentist that I started last lecture. You would go to the dentist and you show him the interface, and you present to him everything that's going to happen, even if you're going to install hardware like camera and projectors in the ceiling, or he's going to be having an extra LCD in front of him. Everything is acted as if actually it is there. Okay, there is really nothing there. It's all paper, but it's lots of paper, and every one the papers are sequenced correctly. So then if he clicks on a specific feature in the interface, the paper changes, or the observer changes the paper. Sorry, the computer changes the paper and displays the right interface for him. Okay, this is how we do it with Paper Prototype. And this is again the script of what I was just mentioning. The facilitator explains the general context and introduces the user to the system. Facilitator asks user to conduct tasks. Facilitator assesses with user the system. facilitator present questionnaires, if any. Okay, so one thing I missed to mention in the previous slide is that the facilitator, or basically the whole team, has to plan the tasks, and this is related to the previous lecture content, which is the task design and the hierarchical task analysis you're going to make sure that you're actually, and applying the heuristics we discussed, to make sure that your task description, the new task I mean, is complete in terms of the number of steps underneath it. Okay, now what you've done here is you've created an interface based on those tasks, and you're experimenting it with the user. But at the beginning, the facilitator needs to tell the user, at least to stress the point, that we are now doing this task, not that one. Okay, so he knows actually what he's about to be doing. Now, what to look for in a paper prototype? We cannot test everything in the paper prototype, of course. Okay, we can look for the functionality. Is it understandable? Okay, does it make sense? Are there any missing features that the user would like to see and we did not support it? Okay. We could also test navigation and task flow, which means, is the user able to find her way in the interface, or he's lost? Okay. Were your assumptions right about the task analysis and the task design? Okay. Are you missing a step? This is one important point in the development of a system where you uncover missing steps. Okay. So if you've missed it, even after applying the heuristics we discussed last time, you can get it from the paper prototype. Okay. You can also test terminology. Are you using the right terminology or not? Okay. For example, there's always a lot of confusion in the banking industry between debit and credit, to whom side, and usually they would refer it from the perspective of the client, not from the bank, because it's the reverse between the bank and the client. Okay. So historically, some banks used to change the terms. So when they refer to debit, they are referring to, you know, what the customer owns is what the customer owe. Okay, because the money is really entrusted in the bank. So it used to be, the terms used to be reversed. Okay. Now you could also test content. Is this what the user would like to see or not? Okay. So all of these are things you can test. What are the limitations? Obviously, anything related to the visuals here and the aesthetics is out of the question, because this is printed on paper. It's not an LCD. It does not have the same resolution or brightness as an LCD, so you cannot test that. Okay. You also cannot test response time. Why? Because you have this computer that's a bit slow, a human being, moving the papers around, and also the user is a bit slow because really everything is fake. There's no keyboard, there's no mouse, and he's going to simulate that, so it will take him more time, obviously. So this is not something you can test. So I have here a complete video of working with just a little bit of a widget, and watch the video. It's linked on YouTube, and it will show you like how far you can go with this. This is really a powerful technique. In spite of the fact that it looks naive and childish, is extremely useful from a user interface point of view. It can enable you to test lots and lots of interfaces very quickly. Okay, with almost zero cost. Now let me tell you that there are other ways you can do prototypes. Okay, there is another way where you can actually build software that has no logic behind it, has no back end behind it, has no engine behind it. It's just the interface. Historically, the very popular tool or language that used to do this is Visual Basic, which is now not as popular as it used to be. And Visual Basic was very popular because you can build like a whole running interface that has no logic behind it at all in just half an hour. Why? Because Visual Basic, which was a product from Microsoft, was the first one to introduce this nice feature that's called Visual Interface Builder. That's what you see here. Nowadays this exists everywhere, okay? But historically only Visual Basic was really good at doing it. And consequently most of user interface developers relied and still do on Visual Basic because of that. So what you see in front of you here are, on the left side, there is a column of user interface controls. You drag and drop them in any way you like, and you organize the screen just like in the real interface you're going to build, and you click on the blue triangle that exists in the middle of the screen there, and suddenly this thing pops up and it's a running program. Okay, now where is the logic, where is the code? It's all has been generated automatically for you and linked together. You could still create any number of forms. This is what it's called, it's a form, and you link them, but then you have to code the links. So when the user clicks on this button in this form, you ask Visual Basic to display the second another form, okay, and you mention it by name, like, if the user presses this button, then activate this form and hide that one. Okay, so you can still even have here an interactive user interface, okay, where you can go back and forth in the interaction, filling in text fields and check boxes and so on, and even displaying some fake information to the user, but there is really no back end, there is no logic, no software has been written. Okay, now this way of presenting or creating prototypes or presenting prototypes is interesting, but there is a catch. Okay, now what's the catch? Obviously this is more realistic than paper because you get something that is running, but now here is the catch. What Visual Basic produces is something that is a very unique look and feel to Visual Basic. Okay, it doesn't look like proper Windows applications in most cases. It doesn't look like a web interface. It doesn't look like an Android application. It looks like nothing but Visual Basic. So for naive users, historically, there has always been a complaint, in the HCI community about using Visual Basic and showing the output to naive users. Because I'll give you an example. Let's say you're building an interface for a system, a whole system, not just the interface, a whole system for a pharmacy, and the pharmacist has your client has no clue about technology. He's a pharmacy guy. So you build the whole interface as a prototype using Visual Basic, and you go and you proudly show it to him and tell him, okay, this is what you're gonna get. Now the first impression he will say is like, I don't like it. Why? Because it doesn't look like anything he knows. It doesn't necessarily look like Windows, because Visual Basic always had this like little touch that make it different from regular Windows. And if you're going to build a website, well, you're going to go for an uphill, with this guy, because this doesn't look like a website in the first place. It's like a desktop application. Okay, so you have to be careful when to show a Visual Basic prototype. And you have to be showing it to a user who appreciates the fact that you are showing him a prototype made in software, but it's not the real thing. When you go and build it, it's going to look completely different in terms of the look and feel of it. Okay, it will not look like Visual Basic. Okay, now again, this is super fast. Okay, you can actually do a prototype very quickly. In a couple of days, you will end up with tens of forms all connected together properly, even though there is no logic at all, there is no database in the back end, there is nothing, there's no functionality, but it all looks real. Buttons, clickable, menus, you can open them, dialogues, you can switch them on and off, and so on. So you can watch this prototype that exists on YouTube again for some kind of an interface that is built as a prototype of an application, and you see how fast this actually gets built and how interactive it is within just a few button clicks. Now here we have to talk about, since we went into Visual Basic, about the prototyping fidelity. Okay, now generally speaking, when we talk about prototypes, we are really referring to horizontal prototypes, which mean the user interface without the rest of the application. So I'll try to model this here with this kind of block diagram. Okay, the top row that exists here is basically the GUI. This is like the front end, the facade of the application, what the user sees. Okay, so the user is standing at the top here, like, where it says different features. This is what the user is looking at, the user interface. Okay, and in a prototype, you have to produce the whole user interface, not just parts of it. Okay, and usually that will be called a horizontal prototype because you covered all the interface horizontally. Okay, but you typically also pick one important feature in the interface and you build a vertical prototype. Now, a vertical prototype means it's actually working. It's the whole system, or it's part of the system working, really working. Okay, and you do that to the most important transaction in your system. For example, if you're doing a stock trading software, the most important transaction is to buy a stock. So the user gets a list of stocks, and he clicks on one of them and say buy, and he enters the amount and say buy. Okay, now that one gets built for real, including even the back end. So you're going to go all the way to the back end, do the transaction, and store the data in a database, and come back with the result of doing that and displaying the message to the user, oh, transaction has been performed, you've bought the stocks. Okay, and you only do it for typically one or two of the important functionalities that you really need to show the user working as they will be really in the real system, in production. Okay, that would be called a vertical prototype, and we rarely do it except when the functionality of us, one of the main functionalities, we are really concerned about its user interface, so we show the whole thing to the user. Otherwise, we're always building a horizontal prototype. Now we come to the third interaction, the third prototyping technique, which is Wizard of Oz. Okay, now, this is really fun. Now, in this thing, you don't even build paper; you build nothing. Okay, what you're going to do is you're going to simulate it using a video, as if it actually exists. Okay, now the quality of your Wizard of Oz prototype is measured by how good you can fake it. Okay. Fake it means not doing it, and I've linked to you here an example of a YouTube video that shows a very old, very famous video that I think I have showed you before when I talked about virtual agents and discussing interaction styles, of a secretary that you talk to do things. Okay, now this is an example of what's called virtual agents, or and the whole thing is fake. I'm putting it here to show you that this whole thing, this whole interface, this whole video is just fake. It's made up in a video studio. There is no software. The device you're looking at does not exist. Okay, all the interaction that is shown in the video is not real. It has been faked by actors and so on. Okay, and some clever computer graphics. Now, why do we do it? Because there is no better way to judge an interaction technique, how you do something using digital devices, than actually doing it. But since in order to do it, you have to build a device, you have to build the system and deploy it and then do it, that makes it unfeasible. Okay, because if you'd like to test something, you go and spend $500,000 to develop a system to try to figure out if the interaction technique is good or bad. It doesn't make sense. But if you actually fake it in a video, then you can watch the video later on and say, okay, is this really good or not? Okay, now faking it here could be done in any way you'd like. You could use a 3D program like Maya or 3D Max, or whatever video editing software. It could also be done by actors in the background pulling things around in front of you, so it seems like actually you're doing it. Okay, it could be done by modeling in Maya or 3D Max a virtual object and then embedding it into the real video of a human being. Like, for example, if you check my my website on YouTube, there is a Wizard of Oz interface for a flying robot. One of the students taking the HCI course was very interested in 3D modeling, so he designed a flying robot and he made it fly inside a program called Maya, and then he took the output and merged it with a video of himself running inside the university. So he was running inside the university and the flying robot was running beside him, or was flying beside him. And in reality, this was all made up. It's a Wizard of Oz. There was no flying robot ever made. Okay, and what he was trying to show is the kind of interaction we would have with a flying robot. Okay, so Wizard of Oz are interesting, but obviously it's all fake. It just gives you a sense of the interaction. And by the way, it's very dangerous to show Wizard of Oz interfaces to actual clients, because what they will see is they will think that they will get, while what you're actually doing is you're just testing the interaction. You have to be careful about that. So, prototypes are a rapid and economic way to materialize and evaluate user interfaces. That's the takeaway. The second takeaway, there are three kinds of prototypes: paper, software, and Wizard of Oz. I'll move now to another topic, which is design patterns. Now you know interaction styles, basic tasks, hierarchical task analysis, prototyping. What remains is to discuss how you're going to build the interface. And what I'm going to tell you is the worst thing you can go about designing interfaces is building them out of your own imagination. Okay? So innovation is a great thing you should always try to follow. You should always try to follow your instinct. You should always try to innovate. But you should also make use of previous experiences. And design patterns is all about that. So let me tell you the story of design patterns and how would you use it in your project, if you need to. So here's the story. There's a very famous architect by the name of Christopher Alexander. Okay? super famous. He's like one of the top names in architecture in the world. And this guy, he noticed something. He noticed that very successful buildings all share certain properties in terms of the layout and how they have been architected. And regardless of where the building is, for a specific type of functionality, there is always the best design. And that design was not revealed right away. It's not like, an architect who got a dream and then went out and built this place. No, it's actually a trial and error process that architects are trying things, and over time they realize that the best design is this. For this specific functionality, it's this specific layout, it's this specific kind of measurements, and so on. For example, since we are in the COVID-19 days, one of the established facts that in the architectural world is that hospitals should be designed in a way that increases the amount of air and sun and heat to the inside of the hospital as much as possible. And what that translates to is actually a building that is not really deep in terms of its width, okay? And from the three corners, there are windows that could be opened to let the air and the sun inside the building for hygiene purposes. So constructing buildings whose, from the facade of the building to the back of the building, say is 50 meters, is not a good idea, because the sun and the air is not going to go everywhere. Okay, so the buildings generally should be narrow and should have three sides that are exposed to the air and the sun. Okay, and the fourth side is actually would connect that wing, if you'd like, to the rest of the hospital. Okay, so hospitals are supposed to be designed in a way that minimizes infections. And actually we have this in Egypt in the old hospitals that were built 50 or 60 years ago, like for example Qasr al-Aini and Mustashfa al-Itali and Mustashfa al-Yunani or al-Ibti and other hospitals that were built many years back, because there were Europeans living in Egypt and they knew about this. Okay, while for example modern hospitals are not built like this. It's not just hospitals, it's all kind of buildings. For example, churches, they are built in a way to enable people to go in and out of the church without colliding with each other. So there is an aisle in the middle for people to enter, and then you have these desks that people sit on, and then there are usually doors on the sides to let people out from the side. So they go from the center and go out, they go in from the center and they go out from the sides. Okay? Same thing for malls. The most impressive malls are the malls that have an open area in the middle in which you can stand and raise your head up and you will see all the shops. We have this in Egypt in City Stars in Madinat Nasr. Okay, when you stand in the middle, you can raise your head up and you see all the 6 or 7 floors. While for example Festival City is not like that. Okay, it's a little bit more constrained in terms of the area in the middle. Now, so what he noticed, he said, okay, for every type of functionality, historically, we have reached to a point, from early days of architects in the Middle Ages or even before that, we know now what is the best design. And he built this catalog with specification. If you'd like to build this type of building with this type of requirement, this is the best layout we know of up till now. Okay? And his book was a massive success because all architects around the world respected his work even before he published his book, But what he was saying made perfect sense. They all knew that. What he really did is he went to very famous architects like himself and others, and he interviewed them and said, okay, if you face this problem, what do you do? And he discovered that most of the well-known architects, they would develop the same solution. And so what he did is he went back to historical buildings, and he kept studying them, and then he came up with this catalog that became very famous afterwards. Now, why this is so interesting? Because you see, design is very hard to describe. It's very hard to articulate, and it's very hard to produce using some kind of a systematic approach. Design is all about innovation, and you see a great design, or when you see a design and it's a great design, you realize that. But if it's not a great design, you don't know what to do. Like, there's no easy way to parameterize or numerically measure how bad a design is, but you know a good one when you see it. Okay, it's a very subjective, actually, mental activity, and it's a very internal mental activity. Okay, design is not like engineering. Engineering, it's 1 + 1 = 2. Design is not like that. So what he did actually was he basically documented the best design that humans have found up till now for every type of building. Okay, now this idea catches on where? Catches on in software engineering. That we have a big problem in software engineering, which is how can we design good software. So software engineers started doing the same activity he did. They started to look up problems and ask people around, that are known to be good developers, when you have faced this problem before, what did you do? And they wrote a number of books, very famous books about software design patterns. Came next are HCIers. They realized this is a very good idea. HCI design is difficult because this is a very, very complex process that involves aesthetics, involves beauty, involves subjective opinion as well. And they started to collect opinions from designers about when they face a specific problem, what do they do? And we now have websites and catalogs of user interface design patterns. The idea is that, given a specific problem, you will learn quickly how to deal with the problem by understanding the existing design patterns. What you get in a pattern catalog is typically the name of the pattern, the problem it's trying to solve, the solution, which is the pattern, in detail, and any related patterns, and as well sometimes also you get the pros, the cons of the pattern. If you use this pattern, what are you going to lose? Okay, what is the disadvantage, or what are the disadvantages of this pattern? Okay, I have put for you here 2 websites that we will review through in the tutorial that are covering patterns, and you will see the different categories of patterns that exist for designing a user interface. And then what I want you in the project, when you are actually specifying the interaction, you have to come up with the user interface, and that's what you're going to build on the paper prototype, and you're going to use these patterns. So instead of actually building it from scratch, trying to innovate or come up with some kind of an interface that is lacking in certain ways, you understand each one of the problems you're trying to solve, and look up the appropriate pattern and use it. Okay, and you can use screenshots from these websites and then print them and make them part of your paper prototype, so you don't actually have to draw the pattern itself. Okay, all these websites have already the patterns drawn, or there are screenshots of these patterns. So in the tutorial we will see all of these patterns, or most of them, and we will discuss the pros and cons of each. So the takeaway: GUI design patterns documents best known solution for common interface problems. Okay, and this is actually going to be your tool when you're building the user interface for your project. And these are the references for today's lecture.